Well, Amsterdam, how's everyone doing? Nothing? Come on. Beautiful. Yeah, that's what I want to hear. Beautiful city, lovely crowd. My name is Yunong. I'm from Netflix, and really excited to be here to share with you our story of how we're slaying monoliths with Node and Docker. So let's get started. Clicker. There we go. So has anyone heard of us? Anyone? Nobody? So we started with this really simple concept, right? Which is, watch your content wherever you want, however you want, on any device. And lately, we've really made this push into originals content as well. So here's a selection of 5 of our really exciting, thrilling original series. Has anyone seen any of these? Anyone? Hooray! Yeah. My favorite is the one in the middle right there, BoJack Horseman. It's this really dark, tragic comedy that tells you about the meaning of life. Yeah, some BoJack fans. Also, over the last year, we've really gone global. When I mean global, I mean everywhere. So all the countries in the red there is where we are. So Netflix is literally everywhere, in the Netherlands, South Korea, everywhere in the world. And so we've got this explosion in content, this explosion in countries, and also we've had this explosion in subscriber growth, right? So from 2011, when we had a little over 20 million subscribers, to today, when we're almost at 85 million subscribers, we really had to scale our stack and our architecture to sort of handle the demand of intense subscriber growth, all the original series, and going global. So let's walk through sort of how that all works, right? So you want to watch Netflix. It's really simple. We're like one of the biggest poster childs of moving off the data center into the cloud. So that's it, right? You move to the cloud. Our engineers are done. They sit at work, watch Netflix. Actually, that's not the case, right? Turns out there is no cloud. It's just someone else's computer. So let's actually look at how we've chosen to evolve our data access APIs along with all of our explosive growth, and how we got to 85 million subscribers and how that all works. So in the beginning, today, we're really known for letting you watch Netflix on every single device out there, right? But in the beginning, a few years ago, many of you may remember, you could only watch it on the browser. And so what did the architecture for that system look like? Well, we had a JVM-based web server. And so this was a Java-based process, and it rendered both the UI and returned the markup to the browser, but as well handled all of the data access within the server. So we're known for our microservices-based architecture. So you can see on the right there, there's a bunch of backend microservices that we need to access. And so each microservice team will provide us with a jar, which is a client that we could use to access all of our data. And there's individual clients for each service, and you get different behavior for each client, right? So let's play a game called Spot the Monolith, right? We're here to slay the monolith. Can anyone see where the monolith is? Going once, going twice, right there. The big JVM-based web server is the monolith. And the reason that it's a monolith is that everything was containing one process, right? Both the UI and the rendering and the data access, all of that. So if you wanted to push an update to the UI, let's say, to show the new original series content, you have to push the process and push the server. If you wanted to update the clients, update the way that you access your data, maybe to make it more efficient or improve caching, again, you have to push the service. And so you have to keep pushing this process when you have to make every little change. And this is not what we wanted, right? And additionally, we got more devices and that came online, and we wanted to support those as part of the Netflix experience. So how do we do that, right? Let's look at the next step in our API evolution. Well, we did what everyone else does when they have a monolith. They take the Java web server, and they turn it into a REST API, right? So we took all the data access that was contained within the one single process, and we made a REST API. And this is what everyone traditionally in the industry does. And this was really good because this unlocked the ability for us to use Netflix on all of these different clients as well, right? Because if you recall, on your TV or on your PlayStation or on your iOS device, there's no markup that's being returned, so you have to be able to access the data from the client anyway. But there were some inefficiencies as well, right? With a rigid REST API, it meant that we were inflexible. So teams are often waiting weeks between API changes. So if you're the iOS team and you want to make a change to the API, you go tell the API team, hey, I want to make a change, and then some weeks later that gets pushed live. So that really stifles our rate of innovation. It was also really inefficient. If you think about it, every single movie that you see on your Netflix app is a REST resource. So if you're returning a list of, say, 100 movies to the user, you're making 100 REST calls and round trips, which is very slow and inefficient. And over time, as we added additional fields and changes to the REST API, it got really unwieldy and complex, and it was hard to maintain. So let's see what we can do, right? We can do better than this. So what does the next step in our API revolution look like? Well, let's look at some of our core tenets on Netflix, right? What sort of are we really looking to do? Like I said before, we want to just rapidly innovate, and our whole ethos is to design for innovation. So you notice that, don't want to brag, but our clients are sort of one of the best in their class for discovering new content, for playback, and all of that. So we want to unlock all of that for all of our teams. This also means, more A/B tests and more Netflix available on all different devices. And the thing that we really want is literally for each team then to be able to write their own customized API, right? Instead of having to use a rigid, non-changing REST API, what if every team could craft their own API and change the way they access their data and suit that exactly to their needs? And lastly, performance matters as well, right? We don't want to be making 100 round trips to load a single page. And so we take the REST API and we turn to something called API.next. And so what we've done here is this big shift in the way that we access data. So instead of having this rigid REST API, now each of these individual teams, whether that's TV or iOS, they can upload in Groovy scripts to a JVM-based server. And these Groovy scripts are custom APIs they craft that handle and access data exactly the way they would want from the backend microservices. So this really unlocked the rapid innovation and sort of the performance benefits, because now you're not making a bunch of round trips. The API that you're crafting is grabbing all the data from the backend, collating, aggregating all of it, and sending it back to the client. But let's play the game again. Can anyone spot the monolith here? Right? It's still we brought the monolith back, except on the server. And so what do we do, right? What should we do? Well, let's talk about our scale as well. This monolith worked really well for a few years, but now as we've hit some of these incredible scaling limits, for example, 42.5 billion hours watched in 2015, billions of requests per day, we have thousands of these, what we call scripts, which are those custom APIs that teams are crafting. They're running in prod, and then we have tens of thousands in tests. And each of these scripts are seeing lots of changes. And we also have hundreds of A/B tests with many variants per test. So the sheer scale of the system is pretty overwhelming. And there's some problems, right? With vertical scale, for example, because all of these scripts and custom APIs are living inside the same physical process, we're quickly running out of vertical scaling space, right? So we're purchasing the biggest, most expensive instances the money can buy, but they're no longer sufficient, and we're seeing memory and I/O pressures. And so that's not good. How about resource contention and process isolation, right? Because everyone lives together inside this homogeneous process, you as an individual team is incented to take up as much memory and disk and I/O as possible. But by doing that, you're sort of going against the group incentive, which is to leave enough space for the rest of your peers who also need to use the shared resource. Additionally, if you're, say, one team, like the TV team or the iOS team, and you deploy a bad script, and that has a problem or a memory leak or has an exception, that takes out everyone else, right? So when you deploy a bad script as one team, you can literally take down all of Netflix, which is not great. And conflicting dependencies and dependency resolution was not that great either, because in Java you can only have one version of each dependency library. So imagine trying to resolve which version of log4j you're trying to use. So all of this made us realize that, hey, there's also an additional aspect of this, which is developer ergonomics, right? Which is that if I split the API server right down the middle, you see that on the left, everything there really belongs to the UI engineer, right? We have the UI engineers who are writing JavaScript on the client for all the clients, and they're writing their own APIs in Groovy, and then systems engineering, which is the backend teams and the API teams, are writing their client libraries and their backend services in Java. And there's a few pain points here. One, which is that we have to write these scripts in Groovy. Does anyone write Groovy? No hands up, right? I wrote some yesterday because we have to work on this. But Groovy isn't sort of a modern language that we want to use anymore. But the biggest problem with developer ergonomics is because this is a monolithic process and it's so heavyweight, it's impossible for you, say, as a UI engineer who's developing these endpoint scripts, to spin that up locally on your own developer machine. You would need hundreds of gigabytes of RAM and hours to wait for it to start up. So instead, what you do when you're testing your scripts is you're uploading your endpoint scripts to a test server. And so you wait for the upload to finish, and then you're trying to test it by hitting the endpoint. And if it breaks, you re-upload the script with a console.log statement to see how things are going. And this turnaround, I see some of you laughing out there, takes tens of minutes and is extremely painful. So developer ergonomics here is terrible, frankly, for our developers, right? This is the number one thing that they complain about. So how do we make this better, right? How do we get to the next level of API evolution, which is really around slaying monoliths? Well, let's look at our requirements. 3 big requirements: scalability, right? We don't want to be vertically constrained inside one process. Availability, we want everything to be available. We don't want one errand script to take down the process. And developer productivity. Our developers never want to have to wait tens of minutes between turnarounds when they're trying to update or test their APIs. So let's talk about the first couple of points: runtime scalability and availability. What does that really mean, right? Well, it means process isolation. Gee, wouldn't it be nice if all of these API scripts were isolated on their own, inside their own processes instead of being co-located inside one monolith Java process. We also want to separate data access scripts and the API servers themselves so we can horizontally scale them individually. This will help us reduce infrastructure costs, and it will lead to faster startup times. It takes like almost an hour right now to start an API server. So imagine suddenly we have a huge surge in customer traffic. It would take us an hour to meet that demand. That's obviously not great either. And we want these scripts to be immutable so that they're easy to debug and troubleshoot. So what about developer productivity, right? Well, 90% of all of our clients are written in JavaScript. So ideally, we want to be able to write JavaScript on the server as well when we're crafting our APIs. Also, one of the biggest pain points that we talked about earlier, we want to be able to run and debug these APIs locally, set breakpoints, step through code, just like how you're developing your Node applications today or your UI clients today. You want to have the same set of tool sets. And that follows with fast incremental builds, so not having to wait hours and hours for a new server build. And you also want an environment that as closely mirrors production as possible. So maybe I can take a production image, bring it down, test it locally, and vice versa. And that'll really help with the developer ergonomics and productivity of it. So what does that look like, right? Well, we take the monolith that's in the old API, which is which is everything glued in together in the one process, and we turn it into something like this. And this is our next generation data access API that we've been working on at Netflix. And I'll walk through this in some detail here. So what we've done is we separated those data access scripts into the Node API, which is the second column. And then we've also provided a common data access API called the remote service layer. So the teams now, the UI teams, are writing Node apps inside containers as part of the Node API. And these containers are horizontally scalable. They're scoped to each individual team. And so now we have that process isolation that we like, and plus they're writing things in Node, so now everything's in JavaScript. And so we're going to drill down a little bit into the Node platform itself and sort of walk through what that all entails, right? So each team gets its own set of Node containers running Docker and Node and Restify. And it's a set of what they inject into the Node container is just their set of data access scripts. And all that stuff runs inside of a Docker container. And these data access scripts do all the traditional things that they used to do with their API, which is fetch data from the data API, change it, munge it, mutate it however they want according to their A/B tests and their different devices. So let's look at the evolutionary traits that we were looking for out of this new platform, right? I think it consists of 4 things, which is the runtime platform, the actual Node platform that you're running on. What do we need from that platform? How about application management? How do we go about managing now, instead of one big monolithic Java process, all these different discrete and disparate Node applications that all these teams are crafting? How about the container infrastructure, right? We have to now run all of this stuff inside of Docker with containers, so how do we manage that? And lastly, developer tools. How do we make it easy for our teams and our developers to craft these APIs easily? So let's look at the first one, the runtime platform. This is a quote I found on Twitter the other day, which is that a full stack developer is one who can add technical depth to any layer of the application. Now, obviously, this was in jest, but I think there's some truth to some of this, which is that for us, we want our UI engineers to concentrate on what they're really great at, which is creating world-class client-side applications, right? And so our aim here was to provide a paved path for data access apps. These engineers, world-class engineers who are really great at writing UIs, they don't have the expertise and sort of don't have the passion of maintaining servers or running servers in production. So our aim was to provide a platform as a service model for these folks so that they can just write their JavaScript, which accesses their data, and not have to worry about metrics or alerts or auto-scaling their apps up and down or load balancing or discovery or analytics. And in fact, the whole point of this, of the Node runtime, is that it integrates all of the Netflix ecosystem, right? All our open source software, which makes running production apps inside of the Netflix ecosystem easy and reliable. We want to integrate that into the Node platform. And so the Node platform is really a production-ready platform. Now, all you have to do is bring your JavaScript business logic, right? So everything else here, like I said, is free. So you don't have to worry about logging or emitting metrics or figuring out what the RPC mechanisms look like. All that is provided to you, to the container and the platform as modules. And additionally, these UI teams are not managing any of the server or the infrastructure, right? They're literally just injecting code, pushing code into the platform, and we take care of all of that for them. So let's talk about the next step, which is application management, right? How do we manage all these different applications that these teams are publishing? Again, the aim here is to make that stuff simple, right? So we want to talk about how we version these applications, how we deploy them, and how we get, once they're deployed, how we get operational insight to see how they're running. So if there's problems, we can debug them. So versioning, there's a bunch of current problems that we have today, which we talked about a little bit earlier, which is that these APIs change all the time. So there's literally hundreds of thousands of different versions that are live. That's inside that monolithic process, and thousands of these are live in production at any one time. And additionally, there's some inconsistency here, right? In the current system, in the monolith, every team has come up organically with their own version scheme. So for example, TV UI uses a build timestamp, and the web team uses a git SHA, and the iOS team uses the version of their app, and Android, I think, uses the integer. But this is wildly inconsistent for everyone, right? And for the API team to manage this, it's actually kind of crazy. So our aim here was to make sure that our versions and our builds are consistent and reproducible. So how do we do that, right? Well, being Node, it seemed actually fairly simple to use Semver. So we standardized on a Semver scheme for all of the different APIs. So every team can publish their Node their Node APIs, and we just simply Semver them. And if you restrict the major and the minor versions and the patch versions, then Semver makes a lot of sense here. So here you can see this is our Node API index. Every single API version that you publish, not only does it get built as a Docker image, so that's immutable, it also gets submitted to our local Node API index, which is kind of like NPM, but for your applications and your services, which is really helpful because if you want to later on revert to a specific version, that version is immutably checked into a central repository. So what about routing, right? Traditionally, the way that we did routing was you would embed each of these different versions and their paths into the client. So again, recall that everyone used wildly inconsistent routing and versioning schemes. The problem here was that if I'm the iOS team or if I'm any team that publishes to an app store, these clients live forever, right? And if we're embedding the versions inside the app itself, it means that I can never update the service endpoint, right? Because if I did and I routed to a new endpoint, then I turned off the old endpoint, all these apps would break. So how could we solve this in the new world where all of these versions are immutable and we can't deploy over the top of them? Which is what we want, right? We want immutable deployment artifacts because it means that we can reliably reproduce all of our different builds. Again, our solution here was to use Semver routing, which is now instead of strictly pinning to a specific version, we can now float and tell all of these clients to float on a major version. So if I'm the iOS team, I push out a client here with caret 1.0.0, which will make this client float on the latest major version of the 1.0 service. Then I can push out different versions of my Node.js service in the backend that's running inside containers, and I'll just automatically route to the latest one. This makes the updates to your service really, really easy because you can keep all the old versions running around in case you warp in, but you know that all the clients that are floating will automatically get to the latest version. Just like how NPM works with your modules, it'll work like this for your services. And this is really handy for being able to easily update your service. So what about deployment, right? At Netflix, there's a whole bunch of different systems involved when it comes to deploying an application. And so we've developed an internal tool called Newt, which is the Netflix workflow toolkit. And this is really its own talk, but we'll release something on this a little bit later. But this really brings together all the different ecosystems and services and toolkits at Netflix and provides a common library and a CLI and API for developers to work with, whether it's bootstrapping their local development environment or deploying the stuff out to production or publishing a specific version of the service. This really makes it easy for them to do that. And operational insights, that's sort of our last point, which is that we want to make sure that we make it easy for you to list and view all the apps in different routes. So this includes capturing all the deployment histories, all the metrics, and providing really rich analytics. And because we're providing a platform that plugs into all of these existing systems on Netflix that have already been built, this makes it really easy for any app that you write to get all of this stuff for free, right? Because we're already publishing metrics and publishing your logs and all of that. So let's talk about the third point of the evolutionary trait, which is our container infrastructure, right? And we've also built something that we plan on open source, which is called Titus, which is our production-grade container management and scheduling service. And for us, the biggest thing is that we want to be able to make sure that we deploy and scale containers reliably inside of our cloud ecosystem, and that meant creating an entire team to handle all of that infrastructure. And again, this is its own talk. My colleagues have given some talks on this, so if you're interested, you should definitely Google and check it out. So lastly, let's talk about developer tools, right? Our aim here is for developer productivity. Remember that we said, hey, all these developers are coming up to us and saying, hey, I don't really ever want to wait 10 minutes between iterations when I'm building my API. So our biggest goal here is to run and debug these scripts locally, get fast and incremental builds, and then give them a local production-like environment so they can easily test their code. But there's still this problem, right, with local development, which is that even if I'm using Docker, right, if I write my JavaScript endpoint scripts, I commit them to the source control management, I still have to build the dependencies and build a Docker image and bring that down locally to be able to test it out. And that step of building and building the dependencies by npm install and the Docker image still takes tens of minutes. So how do we solve this problem, right? We're back to tens of minutes. Well, we've actually created something we think is pretty novel, which unlocks rapid local development. In essence, we deploy a Docker container to all of our engineers' laptops via that new tooling that we talked about. And inside that Docker container, we'll actually map onto the host the workspace of where all your routes live. So you can check out your application, make changes to it, and because there's a mount into the Docker container, then all that stuff gets automatically picked up. And so when we see that you've made changes to your endpoints or your package.json or whatever, we can automatically pick that up and just bounce the service. So instead of taking tens of minutes, this now literally takes seconds. And also because we have a local container running, you get access to all of your logs, you can attach a debugger and step through the code, so you literally have a local development story. So a quick recap on what we talked about today with containers. What containers in Docker really gave us is process isolation. I'm able to isolate all of my different endpoint scripts from each other. And we also get really nice layered dependency management, so it makes it really easy for me to manage my platform, so I can bring a specific version of Node and a specific version of the operating system, et cetera. And there's portability across all these different environments, right? So I can take a production image, download it locally, and test it to see if I can reproduce the bug. And I can take a test image and run it up in the cloud, all just by using a Docker image. And it gives me fast deployment. And again, that single deployment artifact, which is the Docker image, really, really helps with developer productivity and deployment. What about Node, right? Well, we chose to use Node because we want to use JavaScript on both the client and server, and this really unlocks the potential of all of our UI engineers who are experts in JavaScript already anyway. But additionally, it's super fast and performant, right? And it's lightweight and efficient to run locally, so we can run all this stuff locally without having to spend give everyone 100 gigs on a laptop or anything like that. It's non-blocking, which makes as you all know, which makes server-side programming pretty easy. And it's got this superb ecosystem of npm modules, so that anything that you need, these folks can bring in and just use. And it's been built for the web. So a quick recap on the Node platform, right? The things that we want to hit on: developer productivity, first of all, which is that, hey, I never ever want to wait 10 minutes again between iterations, and we sort of unlock that by letting you develop locally. And in terms of scalability and availability, we've taken the monolith, right, and we've broken that down into individual microservices for each of these teams that are isolated. And so now there's better availability. If I'm a team that pushes the bad build, I only take down my service and not everyone else, which is a plus. And I can horizontally scale this stuff out. So what about results, right? We actually just started testing in production via shallow traffic recently. So now we have all of the search traffic that's coming to Netflix is going through the stack. We're not returning the results because it's just shallow traffic, but we plan on sort of going live in production over the next couple of weeks. So it'll be really exciting to see where we'll end up. And we hope that this will be the system that takes us to the maybe 100 million subscribers or 200 million subscribers and really makes this successful. So thanks so much. If any of this was interesting and you feel like you want to contribute, shameless plug, we are hiring. So come talk to me afterwards. But enjoy the rest of your conference. Thank you, everyone.